Hello everyone and welcome to another video about Compose Navigation 3, and in this one we will uh, be doing the setup for Compose Multiplatform. In previous one, if you watched and if you remember, we did the Android setup. For this one we will do the same but for the Compose Multiplatform use case, and are finished. When we are done, it will look 99% the same, just it will differ in how we do backstack setup, the initial backstack setup, and we will see why those two are different. So let's start. For this example, I will be using Compose Multiplatform version 1.10.0 since it's stable from a couple of days ago at the time of filming this video, and its navigation 3 version is in Alpha 6 stage. Let's begin, and first we will do the most basic and non-typesafe version, and I'll be repeating what I've talked about in Android one, since this is not since the Android one is not a prerequisite for watching this one. In the navigation 3, the philosophy is that we own everything. We construct our own backstack, we keep track of the app state, and the navigation library is just doing transitions and navigations between the two screens, but we are no longer coding against some black box API. We control our backstack and our navigation state. So we will start, because we control it, we will start by creating our own backstack, which will for now be just a mutable state list of any, because we will do a non-typesafe version for now. So this is how we create a backstack. We also want to display it, so we will call navDisplay. This is your navigation's entry point. We will give it our backstack, and we need to give it our entries. So it's done with entryProvider, and for this non-typesafe version, we are getting key. Keys are our navigation routes from this list, and we need to check which one did we get. For now, just to satisfy the compiler, I will just do this, and our compiler is satisfied. And if you run this right now, we will get a crash, because, yeah, we are getting a crash, because our navigation backstack cannot be empty, and that's what we have right now. To fix that, we will define our initial screen, and only for now, and I will use one of existing onboarding 1, 2, 3, or 4 in order to show it, and I will have this, like onboarding 1, and when we are getting a key that is onboarding 1, we will show nav entry with onboarding 1 screen. And if we now run this, we will see our onboarding 1 screen. Yeah, and as you can see, I am calling this one from the main activity instead of the Android one, so everything is fine. We can do that for other routes that we have, but as you can see, it will grow pretty repetitive pretty fast. So we will have this. And if we run this right now, you will see that we are seeing the first screen, but when we enter the first name, we cannot navigate to another one. Why? Because now we own a backstack and we need to add to or remove from it. And when onboarding 1, next button is clicked, we will call backstack onboarding 2. And if we run the app right now, let's see what do we get. Our step 1 in the onboarding as previously, and then we go to step 2. If we go next on step 2, we will not see step 3, because like for the first one, we need to add to our backstack, and we will add onboarding 3. If you run it right now, then you will see that we will go to onboarding 3. So step 2, step 3. But when we click back button, we don't go anywhere. Again, we own our back stack, and on back on each screen, but on back clicked, we will need to pop our back stack. And because we own it, we need to remove from it. So we will remove last. Let's again go to the step 3 and navigate back. We will repeat the same thing for our onboarding 2, and we will leave this one empty for now. You don't need to call remove last or null. You can, for example, do this. It will also work. What is important is that you maintain the correct backstack. How you do it, it's not important. You can even do plus a sign. You can do add, whatever. And if you run the app again, you will see that it doesn't matter how, it just matters that you have your backstack maintained. We can go here, and then we can go back from here, and we will not do anything because it's not implemented for step 1. As you can see, we have problems with this one. Our first problem is boilerplate. We need to define nav entry for each one. So that is the first problem that we will address. For this one, there is a different overload of the nav display composable that takes entryProvider, which does not take key, but it gives us a DSL to define our entries. So we will go onboarding 1, and for onboarding 1, we will have this. We will repeat this for every other entry that we have. So we will have entry for onboarding 2. We will have entry for onboarding 3. And we will add entry for our onboarding 4, since we have it and we will use it, but right now we don't actually have it. Onboarding 4, done, and on back clicked, and we need to define it here. Also, we will navigate to it from here. Backstack plus equals onboarding 4. Here we will do backstack remove last or null. If we run this right now, you will see that we can go 2, 3, 4. We did not implement this one yet, and we go 3, 2. If you remember, on Android, this is how we construct our backstack in the end. So this is, remember, nav backstack, and if you take a look, it's of the type nav backstack of NavKey. And we discussed why we cannot do this in multiplatform. That's because this is using reflection to collect all different nav keys and construct context serializable module for all nav keys, and you simply don't have this single parameter overload for the remember nav backstack entry. And we can try to call it, and it is, as you can see, the one that we are given expects configuration, saved state configuration, which defines a serializer module. Why it is important? Why would you use this one? You would use this one if you really want to have your entries, your routes, screens, whatever, extend NavKey. But then you will need, if you know how to, but then you will need to define serializer module by yourself, and each time add new screen that you add it to the module. We'll go ahead and create our configuration. So it will be, well, configuration is saved state configuration, and serializer module, we need to define that one also, because if you see it is checking for it in the configuration, and it expects it to be passed here, because we don't have the same reflection as on JVM, we need to define serializer module for polymorphism, if you know how that works on the Kotlin-X serialization library. But if you don't, this is how you do it. You have NavKey as a base class, and then you will define, you need to define every single overload, every single instance of NavKey that you would expect to have. We'll go ahead and add everything that we have here, every single one of our screens. And we do that using a subclass, and you need to pass its serializer. We don't have it at the moment because we are not marking these as serializable. We will go ahead and do that for every single one. And now you see that it is satisfied. What we will do is we will pass our configuration and our initial route. It will be onboarding one, route or screen, doesn't matter how you call it. And if we run it right now, we are getting the same result as before. So that's fine. And you don't get the single overload, the single parameter overload for multiplatform, since there is no reflection. Again, you see that we have NavKey for every single screen that we want. And if we are to add a new one, onboarding 5, then we would need to manually go and add onboarding 5 to our polymorphic subclass serializer module. This is fine if you really, for some reason, for interoperability, maybe you have different modules that on Android, and Android is your main thing, but you want to gradually move to multi-platform, and then you have NavKeys inside of there too, and you really want to have NavKey as the parent of every single screen that you have. But in the pure multi-platform, this is not really ideal, and we will address that now. The next step is to remove the need to have this serializers module. We are doing this because we have a polymorphic NavKey for our classes, and there is no reflection. So you have open and closed polymorphism, and we will have, this is open polymorphism in Kotlin-X serialization library. That's how it's called. And you need to define every subclass, but when you have closed polymorphism that is either having sealed interfaces or sealed classes, you don't need to have every single subclass definition defined like this. And that's what we are going to do now. So we will have parent serializable, sealed interface, screen, and we will replace every single one of these with screen. That way, even compiler is complaining right now, so we will delete this, but now we don't have a configuration for our backstack. Now we will change the approach, and we will call remember serializable with a serializer that we are provided by the Compose itself. So we have snapshot state serializer. So we will have mutable state list of screen. And with serializer defined like this, you see that now we are in a mix of the two approaches that we saw before, but now we are using type-safe navigation, and we are surviving configuration changes and process that's on Android. That's important. And if we take a look into remember serializable, you will see that it survives using safe instance state, plug for Compose, which is saver. They define saver for the configuration and the serializer that you passed, and then they're calling remember savable. What is funny that I've noticed that they're using a lot of deprecated APIs, but it's not our business. It's just funny thing that I've noticed. And remember savable survives both configuration changes and process deaths, where remember survives only configuration changes. This is more important for Android than other platforms. And this one we can run pretty much as it is and see the final result. We're getting the crash. Let's see what it is this time. We cannot have empty, of course, as we seen already. So if we now run it again, we see, and we can navigate to other screens. The one thing that we are missing is the ability to pass things around, and we'll do that right now. If you see onboarding 2, it accepts the name, onboarding 3 accepts the full name. We need to pass that somehow, and how we will do that is like this. This is the same how you do it in navigation 2, but if you are not familiar, don't worry. So it's name of type string, and here we have full name of that type string. It will be that class. Now we have errors here, and we can pass. As you can see, it is a string that is the one that we enter the name. That this is a very simple screen with just a text field, and whichever name we enter is the one that we get when we click on next. It is the same for every other screen. Here we get on the onboarding tool, we are getting only the last name, so we will need to construct it. So this is last name. It being the onboarding tool, name plus last name, and then we will pass full name here. We also need to change those because we are passing them right now. So hello full name. If we run it right now, you will see that now we have A, hello A, B, AB, complete. We are done. Go to step 4. Just, I don't like seeing, these two be different, so I'll do it. So I'll do this, and to demonstrate that we can do basically whatever we want with our backstack right now, we can do, when we are done with the onboarding, we will do shuffle and shuffle all of these screens around and see that we have a full control over our backstack. So now we'll have again A, B, complete, done. So now they are shuffled, we have complete control over it, and then when we pop, doesn't matter which way we go, and now it will crash because the backstack is empty. That's it, what we have for the Compose Multiplatform setup. Thank you very much for watching this, and in the next one we will see how we can have view models scoped for each entry. So we are not scoping to the nearest activity or fragment or whatever, and we will write our own scoped view models with for Kotlin inject. If you would like to see Android specific one, that is in this one. We done that in a previous video. I will have it linked down in the description below, and see you.